I'd like to welcome Avi Goldfarb to the Center for Competition Policy seminar series. We're really delighted to have you with us today, talking about the adoption of artificial intelligence at the system level. And we'll be running until 2 o'clock for the main part of the seminar, and then we may break and close off the official part of the seminar. And if anyone who wants to stay around for a virtual tea is very welcome to do that. So over to you, Avi, and thank you very much for coming.
Great, thank you. I'll get my slides up. Hold on a sec, sorry. It's a pleasure to be here, or to at least be sort of virtually here. I've known Michael since he was a doctoral student, and I've been following his career and a big fan of his work, and it's been sort of happy to take the opportunity to come talk to his colleagues in his group. Okay, so I'm gonna, as I do this, I'm gonna keep the chat open so that if anybody has any questions, please either enter them in the chat. I also have many of you, at least your pictures up, so if you can also raise hands. Okay, so I'm Avi Goldfarb. I am a marketing professor at Rotman in Toronto, and my career has been focused on studying the economics of technology, starting way back in the late 90s when there was this new thing called the internet, trying to get my head around that. And that was my dissertation. And in fact, about search engine competition, back when there really was search engine competition. And now, over the past 6 years or so, I've been thinking more about AI and what AI means for the economy and for firms, and to some extent for competition. I'm going to get at that at the very, very end of the talk. So there's a lot of hype around AI. We have this sense that business adoption of AI is going to surge. And alongside the hype and excitement, there's a little bit of anxiety. So, if the AI is advancing, what are we humans for? What's our role in this grand scheme of things if we have machines that are intelligent? We've accepted that machines can be stronger than us, but we haven't quite accepted that machines might be smarter than us. Underlying both the excitement and the anxiety is really confusion about what we're talking about when we're talking about AI. So if you read the press, you might see something optimistic, which is C-3PO or the droids from Star Wars. Why is that optimistic? They are machines that can do just about everything humans do, but they do at least one thing better than human. Yeah, they do. They're machines. They can go out in space and all that. But the thing that they really do better than humans is that they listen to humans, and that makes that optimistic artificial general intelligence. The rest of science fiction, of course, is filled with machines that can't, that do everything we can do, or even do it better, but don't listen to us, whether it's Skynet or the rope droids from the Matrix or HAL from 2001: A Space Odyssey. I used to think this idea of an artificial general intelligence was crazy. After a conference we hosted in 2017, where Daniel Kahneman and Jan LeCun discussed and debated that idea, I no longer think it's crazy. But it's important to recognize that it is 20 to 50 years away. And it has been 20 to 50 years away since the very first AI conference at Dartmouth College in 1956. This is not the technology we're talking about today when we're talking about AI. We're talking about a very particular field, subfield of AI, really a field of computational statistics called machine learning. And the biggest advances have been a subfield of machine learning called deep learning. What's that? Well, computational statistics, it's prediction. It's using information you have to generate information you don't have. What's changed in the last decade is that computational stats, prediction technology, has gotten much, much better. And once you understand that framing, you can think through, what does the technology change? What does it mean? Think about it as predictions gotten better, faster, cheaper. So as economists, half of you are economists, right? So we think about these changes as a drop in the cost of something. And we like to think about it as a drop in the cost of prediction. So prediction has gotten better, faster, cheaper. Somewhere around 2012, there was a change in the trajectory of the drop in the cost of prediction. Okay. So Okay, so now I'm going to summarize, just do a quick summary. So wrote this book, Prediction Machines, which is up here. Okay, looks like this. Okay, so the key theme of that book came out a few years ago, is that we should think about AI as dropping the cost of prediction. And that means that we're going to identify, demand curve slope downward. We know that from economics. So when the cost of something falls, we're going to do more of it. We're going to start with more prediction in industries that have always done prediction, like insurance and banking. And then over time, we're going to start making predictions in areas that we didn't make predictions before. As prediction gets cheaper and cheaper and cheaper, we're going to start to realize machine prediction is useful in other contexts. For example, potentially medical diagnosis. What does your doctor do when they diagnose you? They take in data about your symptoms and fill in the missing information of the cause of those symptoms. That's prediction. So that's Econ 101. Day one is demand curve slope downward. Theme number 2 of that book is your second day of Econ 101, which is when something gets cheaper, then the substitutes for it become less valuable and the complements become more valuable. If coffee gets cheap, we buy more coffee, we buy less tea, we buy more cream and sugar. When prediction gets cheap, we use machine prediction more. When machine prediction gets cheap, I should say, we use human prediction less. That's a substitute. And we are going to use data more and judgment more. Those are the complements. And judgment being knowing what to do with a prediction once you have one. Ultimately, it's the payoffs, the end of a decision tree, for those of you who think like economists. Okay. So that was that book. And then we started to think about the broader consequences. And the vast majority of the time when we talk to companies or we see it even discussed in economic literature, AI is framed as a tool for a task. What do I mean by that? It's framed in this economic literature of the task-based model that in the AI context is Acemoglu-Restrepo, and in the labor economics world is Acemoglu and Otter, their Journal of Labor Economics, their Handbook of Labor Economics paper from 2012. And the idea of a task-based model is you can represent labor, you can represent jobs as a series of tasks. And each of those tasks requires skills. And so demand for human skill depends on the tasks that are demanded in the job market. And you can model the impact of AI, robots more generally, I should say robots in particular, as you're taking out a human from a task within a workflow and you're putting in a machine. And so the dominant way that the econ literature currently frames AI, currently frames this machine learning technology, is that a job has a series of tasks. Some of those tasks are tasks that machines can do, whether as robots or as prediction tasks. We're going to take out the human and we're going to put in the machine. So you have a workflow, you figure out the tasks, you figure out the decisions, and for each of those tasks that are, those tasks are within jobs, for each of those tasks that a machine can do, because AI has gotten better, technology can now do what couldn't before, you're going to take out the human, put in the machine. And that's going to change, it's going to increase productivity incrementally because the machine presumably is better at it than the human. That's why you're taking out the human, putting in the machine. And then there's, in the long run, there's reasons to be, to say, well, that's going to improve productivity overall. Yes, even though we might have less humans, Baumol's cost disease says we're going to rebalance the economy and things will end up fine. Okay. End up could, the long run could be a long time. Manuel Trachtenberg pointed out that if there's a revolution in the short run, we don't care about the long run. So Manuel Trachtenberg, if you don't know, he's one of the leaders of leading researchers in economics technology from sort of the 90s. His most influential work appeared in the 90s. And then he went into politics in Israel and was senior in the left-wing party at the time. Probably had they won, he would have been finance minister, but he understood the politics, and he was at our conference after he left politics and gone back to academia. He was at our conference again in that 2017 conference, and we were talking about, do we care? Is this a big deal if in the long run, people will find jobs just like they did in agriculture? Yeah, agriculture is not a big part of the US economy, but there's still plenty of jobs there. His comment was, yes, it's a big deal because if there's a revolution in the short run, then we might not get to the long run. How does this play out in a business context? So take retail. I'm a marketing professor. I think about retail a fair bit. So you go to Amazon, and Amazon recommends these things to you. Okay? And this is largely done with machine learning. These are based on your past purchases and the past purchases of others. They predict what you're likely to buy next. And they're actually it's pretty extraordinary. They're very good at this. What do I mean by that? From as far as we can tell, they're right something like 1 out of every 20 times. Don't know exactly. It's trade secret how good they are, but whether it's 1 out of 20 or 1 out of 40 or 1 out of 10, somewhere in that order of magnitude, and that's pretty extraordinary, right? They have hundreds of millions of items in their catalog, and 1 out of every, say, 20 times they get it right. Okay, so there is a task within the workflow of recommending what you want, and they're going to use a machine to figure out the right recommendation for you, as opposed to just recommending everybody get the most popular item on Amazon, right? That's how we used to do it in the old days, in where you go into a store and you basically get recommended the most popular item in the store, or that would be in the early days of e-commerce. That's effectively how it worked too. Okay, and then so that's Amazon's main prediction, the prediction that we sort of see most obviously. There's another prediction at Amazon, which is what to stock in inventory. Okay, so they make predictions about what to stock in inventory in order to make the shipping efficient. So if they, right, because if people are ordering something that they're not stocking, then that, then their shipping is going to be very, very delayed. This is a prediction that retailers have been making for as long as there's been retailers. What are people going to buy? What do they need to hold in inventory? So these are both machines that are tools for tasks. Here's a machine that is helping with the task of recommendation. Here's a machine, an AI, that's helping with the task of demand forecasting, ultimately. This, I should say, is the macro level. This is the micro level in some sense. Insurance, we see the same kind of thing. We see there's the main prediction that you might think of in the insurance industry, which is underwriting. How risky is this person? How likely are they to make a claim, and how big is that claim going to be? And there's another prediction in insurance, which is a marketing prediction about who they should target with their marketing messages. These are both tools ultimately within the insurance company. The underwriting prediction is a prediction that they have had teams of humans do for decades, using some machines, but lots of actual just brute force, at least conditional means, and not much more than that. And increasingly, they're using machine learning tools to help with that underwriting, and that is making the workflow more efficient and taking some humans out of the workflow. Maybe putting other humans in because they're good at machine learning, but taking some humans out of that underwriting workflow. Marketing, similarly, what's the machine doing? It's telling them which customers to market to. It's giving recommendations who's likely to buy. Ideally, they'd be doing the conditional, which is who's likely to buy conditional on getting a message, compared to who's likely to buy in the unconditional, like the causal impact of advertising. Maybe they're doing that, maybe not the ones I've spoke to, but at least they're doing predictions on getting their messaging out, who's likely to buy. And those machine predictions are, that used to be a task in a human workflow of identifying targets. And that task is increasingly done by the machine. But it's not changing the way the organization operates in any way. There's a workflow, and here's a prediction task, and they drop in the machine and take out the human. And that really is the way that we think about AI, both at the organization level. If you read how to implement AI type books, and or talk to people who are trying to make it happen in their companies. And for that matter, it's the dominant model in economics because it's the Acemoglu Auto Restrepo model. Okay. So Tim Bresnahan. So Tim Bresnahan this is a competition group, so you probably know who he is. But so Tim, in July 2019, came to me at the NBER and said, "You guys keep." Oh, a little bit of background. So we run this NBER Economics of AI conference, right? Every year. We've run it since 2017, 2018, 2019, and it was by July 2019, sort of in advance of our conference, it was becoming clear that the canonical framework for dealing with technology adoption in organizations, particularly on the labor market, and just to think about the impact of AI was this task-based model. And Tim took me aside at digitization meetings in July 2019 and said, "I hate the task-based model. You guys keep promoting the task-based model, it's garbage." Okay. And I was like, "Okay, so Tim, can you explain what's going on?" He said, "Well, the task-based model by definition means that the impact of this technology is going to be incremental. It's going to improve productivity, but since the economy as a whole doesn't really reorder or change, all that's going to happen is you're going to have incremental productivity boosts." And so Acemoglu Restrepo, when they do their work and their macro models, they set it up so that there's no way for AI to be anything but incremental, and it becomes a relatively pessimistic view of the impact of technology. Yeah, it's going to incrementally improve productivity at the cost of lots and lots of jobs, is sort of the punchline there. And he said, "That's garbage. We know from," maybe I'm paraphrasing a little too aggressively, but I don't think so. "We know from the work on AI, from other information technology, that the impact isn't at the task-based level. The impact is largest when companies can change the way they operate." So he said it's a systems-based approach, not a task-based approach. So I went back to Joshua and Jay and Catherine, who co-organized the conference with me, and we said, "Well, why don't we have Tim and David and Pasquale debate this at the conference as part of a panel?" And if you're interested, the debate's on YouTube. It's it was a pretty interesting discussion, I think. And my sense is nobody was convinced by Tim except for Ajay, Joshua, and I. Okay, so ultimately, and Shane Greenstein, I should say, because Tim was based on work with Shane. Tim's framing on the impact of AI being like the impact of other IT was based on his 1999 Journal of Industrial Economics with Shane. And so that led to us thinking about what does it really mean to think about things at the system level, okay? And so, in the business school framework, that's what does it mean to think about AI strategy, so this image, as an aside, this image comes from prediction machines. So we do have a discussion of strategy in prediction machines. We just decided at the end of it's not the best part of the book. We thought about strategy, but the book has been influential on thinking about the impact of AI. But I think that's because we get the prediction, decision-making, and tools part really right. We have ideas on strategy, but our strategic implications are more about tools for tasks than strategy. There are things like you should worry about bias. You should think about the ability to make different kinds of contracts, etc. Nothing like totally transformative to an organization. Very little, I should say, not nothing. Very little totally transformative beyond imagination. So, so after the book was out, which was 2018, after this conference, we sat down and said, okay, well, let's try to get our heads around this. And our starting point was Tim, a few months later, wrote up his ideas as a chapter in a forthcoming book. And he called it AI Technologies and Aggregate Growth Prospects. And so this was him trying to take, so here, okay, I told you that I wasn't overly aggressive in quoting Tim. My empirical conclusion about these applications is that the lazy idea of artificial intelligence, of computer systems that are able to perform productive tasks previously done by humans, is irrelevant to understanding how these technologies create value. So pretty strong words, okay? And then he says it doesn't mean, here irrelevant doesn't mean it's less important. Here, it means irrelevant. He's coming out swinging. Okay. So we read the chapter with interest, and one of the core ideas he emphasizes is AI adoption is going to be strongest when organizations are modular. Okay. What's a modular organization? It's an organization that benefits from prediction and coordination across tasks, but better prediction in one task won't help improve coordination. Okay, so that's a modular organization, and so he emphasizes that adoption is higher when you have modular systems, but that's inconsistent with his opening, right? So his opening says it's the task-based model is irrelevant. We need to think about systems changes, but in a modular organization, you can't really change the system. The whole point is you can think about one task as separate from another. Michael.
Sorry, I had to unmute. It just seems to me that, okay, I'm trying to square my head around, but maybe that's where you're heading. It seems to me that this type of transformational change has to be disruptive and has to bring down established organizations, because new ones come up that are able to kind of start from scratch. Because once you have an established structure, it seems to be, except if you're extremely modular, but then otherwise you're going to get stuck with the established stuff.
Yeah, no, we're not quite going to get there, but we have a model that's a first step toward getting there. Let's put it, which is that organizations have to do things differently in order for AI to have a big impact. So, but our model is going to be, it's relatively simple. For those of you who are modelers, it's very simple. For those of you who don't really think in economic models, it's going to seem like crazy Greek, but assuming you don't think in economic models and don't read Greek. Okay. Right. Yeah. So exactly. And so in a modular system, AI adoption is useful and incremental. Who cares? Okay. So let's go back to our Amazon recommendation engine and try to think about the decisions in Amazon. So we're going to try to simplify. I'm going to create a simple model based on these two decisions. So decision number one being, and figure out a way to model modularity, right? Okay. So two decisions, one being how to recommend to customers and one being what to hold in inventory. And so if you get, and there's a standalone payoff and an alignment payoff. So the standalone payoff, what do I mean by that? It's if you get the recommendation exactly right, you help the customer find the best match for their preferences or a better match. But if you get the recommendation a little bit wrong, the customer might still value that. It's just going to be a little bit less than they otherwise would have. So they still value, and there's lots of things that a customer might go to Amazon to buy. If you get it exactly right, you get, you wow them, you get a little bit of extra money, but they might still buy something. So this is getting the recommendation exactly right gives you a standalone payoff, but there's still also an additional alignment payoff, which is that if you recommend something and you hold it in inventory, you get efficient delivery. In contrast, if you recommend something and you don't hold it in inventory, then delivery takes longer. And so you don't get that alignment payoff. Right now, the way Amazon operates, these two decisions are modular because you can get the alignment payoff even if the recommendation is wrong, because you're holding something else in inventory and they might still buy it. It's just not the perfect thing. You're getting this customer the second best item. And there's a standalone payoff to getting the best match because the customer might buy it, but still have to wait a little bit. So there's still some benefit there. So that's the current Amazon system. An alternative, better aligned, fully integrated system is Stitch Fix. Okay, what's Stitch Fix? Stitch Fix sends you stuff every month. You don't order it. Their recommendations are fully integrated with their inventory choice because they take the recommendation, they figure out what you want, and they ship it to your door. And then you make the decision at your door whether you want to buy something, whether you want to keep it, or you can ship it back. But shipping back is a pain for both Stitch Fix and you. So it's really, they want to get both the recommendation and the inventory decisions integrated and right. There's no point in making the right. And then just the business model doesn't really, you don't ship anything if you make a recommendation but can't ship it because you don't have the inventory. And if you don't make the recommendation, who cares if you have an inventory? It doesn't benefit your company anymore at all, right? So it's all about that. Stitch Fix is the AI driving the system of integration between the AI, the recommendation AI, and the inventory AI. So we're going to formalize this now based on Van Steen's formal theory of strategy. So I wasn't sure, to be honest, I wasn't sure how to balance for this audience the formal econ with the background motivation. So speed me up or slow me down as you want through the formal part. The formal part, I sort of have budgeted about a half an hour for it, but it can easily take an hour and it can easily take 5 minutes. So, but I'd planned on about a half an hour. Okay.
I think that sounds fine.
Okay, thanks, Sean. Okay, so here we go. This is a direct quote from the paper. So here's the basic model. We have two decisions. You can think about this as the recommendation engine and this as the inventory holding decision. And oops, didn't, okay. I don't know what happened here. Oh, well. So we have the payoffs are pretty much summarized here, which is that for simplicity, we're just going to say for a standalone payoff, you only get it from the recommendation engine. Don't worry about, there's no standalone payoff from holding something in inventory. We could add that. It just puts an extra letter in the model without loss of generality. Like it just makes things uglier. So we're going to have a payoff for getting the recommendation right. We're going to have a payoff for getting the recommendation decision aligned with the inventory decision. We're also going to allow for an additional a separate payoff. So instead of alpha plus gamma, so if we get these aligned, you'd think we get alpha plus gamma, but in organizations that are well integrated, instead of alpha plus gamma, we get some beta. And we're going to assume that beta is bigger than alpha plus gamma. It's the extra payoff to being non-modular, to being integrated, okay? So your M is your degree of modularity, and the payoff, the reward, the payoff is, for the organization is ultimately simple, but I'm going to walk you through it, which is because it's ultimately simple, but describing it in letters turns out to look not so simple. Okay, so for a modular organization, let's say, for M equals 1, for a fully modular organization, you're going to get alpha if decision maker 1 makes the right decision. Okay, so there's uncertainty about the state, and you're going to get alpha if the decision maker makes the right decision. You're also in a modular organization going to get gamma if decision maker 2 aligns with decision maker 1. Irrespective of whether decision maker 1 actually makes the right decision. This is about whether these two make the same decision. So you can imagine you hold an inventory, what you recommend, you get gamma, but you don't really recommend the best thing for that particular person, so you don't get alpha. Or you do recommend the right thing for that particular person, you get alpha, but it's not what you have in inventory, so you don't get gamma. That's a modular organization. A non-modular organization, so when M equals 0, at the other extreme, what you're going to get is you're only going to get a payoff if you both get the recommendation right and the shipping decision, or the inventory decision right. Okay, and so that's going to happen. That's the Stitch Fix story, and then you get beta, and beta is going to be greater than alpha plus gamma. So, and then modularity is continuous. So I just thought about it at the extreme of 0 versus 1, but you can have any level of modularity for the organization. Okay, so what does that mean in a task-based model? Oh, I'm missing a lot. I'm missing a slide. Okay, going to extract that slide. One other thing that didn't show up in on the slide there. How do you know what's right? So I just need something. Oh, I see what happened. I pasted the same thing in twice. And so everything got messed up. Okay. So I described what modularity is. This is our what to recommend, what to hold. But in Stitch Fix, it's non-modular. Okay, I talked about that already. Okay, here's what I haven't described: the information structure. So there's lots of possible actions. Okay, so infinitely many, in fact. That's without loss of generality, but easier. So the agents can't guess the correct action in general, with one exception. There's one thing that's what we call the focal action. And that focal action has a positive probability of happening. Okay, so there's one focal action that's more likely to be true than all the other actions. You can think about that as maybe recommend the most popular product and hold the most popular product in inventory. Okay. So this focal action means that you can always generate a payoff of alpha 1 or of alpha if you get the, in a modular organization, if you do the focal action. And then that also means that agent 2 is always going to be better off just guessing the focal action. In the absence of extra information, agent 1 should guess the focal action because it's most likely. And decision maker 2, agent 2, should also guess the focal action because that's what they think agent 1's going to do. And that's an equilibrium. In principle, there's multiple equilibria. So as long as agent 1 and agent 2 are doing the same thing, it's an equilibrium, Nash equilibrium, because no one's going to deviate. But that said, the focal, it's going to be, once you do some equilibrium refinements or just think intuitively, you're going to get everybody doing the focal action because it's the highest payoff outcome, where the other ones are, they're equilibria, but the chances of randomly coordinating on that equilibrium are effectively 0, or measure 0 anyway. So proposition 1, there's a Nash equilibrium where everybody does the focal action. Okay. Now let's bring in an AI. So what's an AI? An AI tells agent 1 what the right state is. So agent 1 now might do something other than the focal action. Okay, because they know with some, they now know with certainty when the correct decision is not the focal action. What's perhaps a little surprising at first, although once you think about it, it's obvious, is that agent 2, whose job is to align with agent 1, is always just going to still choose the focal action. Because in the absence of communication between agent 1 and agent 2, the way this organization has traditionally operated, in how we're thinking about it, even though agent 1 sometimes has this better prediction and could do something to get the standalone payoff alpha, agent 2 has no way of knowing what that alternative state is. And so they're going to stick with the one that's most likely to give them a payoff. So this is, no matter what agent 1 does, agent 2 is going to choose the focal action. So the total payoff, if agent 1 follows the prediction, so if agent 1 adopts AI, our payoff is going to be, in a modular organization, they're going to get alpha for sure. Okay, but only given the probability of the focal action being the right action, are they also going to get gamma. In a non-modular organization, the AI doesn't help them at all. So in a non-modular organization, they're still going to get the chance of the focal action being the true action times that non-modular payoff beta. Because in the non-modular organization, there's no benefit to them being right, but not aligned with the other decision maker. So without organizational change, Tim Bresnahan is exactly right. Okay, we are in something like a task-based model. Without organizational change, there's a benefit to following the AI prediction in a non-modular organization, or sorry, in a modular organization, because the AI is going to give you alpha. Like that's where the benefit is in the modular part of the payoff. In the non-modular part of the payoff, there's no benefit to using the AI. All right, and so it's going to be, when you compare, it's going to be pretty straightforward in that with the AI, you get alpha for sure, but the alignment payoff gamma you only get with probability rho, the probability that the focal action is the right action. Without the AI, you only get alpha if it's the focal action, if the focal action is the right state, but you always get gamma because everybody always does the focal action. And so the AI adoption is going to be driven by alpha relative to gamma. And it's all going to be about extra payoffs for modular organizations. Because in non-modular organizations, it makes no difference. We can walk through this in the context. So, right. So if there's a new recommendation engine that recommends products that are out of stock, but difficult to handle, these will require some coordination. If instead it's based on the focal action, then it might be hard or impossible to realize gamma. And so even though the recommendation engine might do a better job, it still might not be worth it to adopt. And so what this is going to give us is this figure of gamma relative to alpha. And so this is alignment payoff relative to standalone payoff for getting the recommendation engine decision right. And rho being the likelihood that the focal action is the right action. And so we can divide this into 4 buckets. So if the focal action isn't that important, then, or sorry, isn't that common, then we're going to benefit from AI in modular organizations. Okay. Because now we're just going to be more likely to get alpha than gamma. We'll come here. If the alignment payoff is relatively high, we don't want AI. We're not going to use it. We're just going to focus on the alignment payoff. Modular organization. If the focal action is really common, we're still not going to have an AI, but we'll be best off being non-modular because we're so likely to get that beta payoff, that extra boost relative to the alpha and the gamma. And then this is a little bit weird, but if the straight payoff from getting the alignment isn't that high, but the focal action is common, then you're going to adopt AI and prefer to be in a non-modular organization. So you're going to want both of those things, but you're never going to use the AI. Like you're still never going to be aligned outside the standalone payoff. So I'm going to walk through how we think about each of these in the context of different industries, or in the context of retail. So you don't have an AI in your modular in terms of the recommendations and the inventory. That's traditional retail, effectively. You walk into the store, there's somebody there who might recommend something to you, but really you don't have much of a recommendation engine. it's a modular organization. The recommendation choices don't speak that much to the inventory choices. A modular organization where you have an AI recommendation engine a modular organization where you have an AI recommendation engine and you also have an inventory decision, that's Amazon. We've talked about it a few times. Peter, I'll get to your question in a second. No AI, but non-modular is like a book of the month club. So in 1926, this thing started called the Book of the Month Club, which became a big deal for a while, where they would send everybody who was a subscriber to the club the same book. Okay, so that is the recommendation and the shipping decision are fully integrated. Right, everybody gets the same book, but there's no real AI. Everybody gets the same book. Okay, so there's no attempt at really matching the right state to the right person. There's a little bit of that going on in sort of more recently in the Columbia Records, Columbia House Records, where they used to ship records and CDs to your door. But then, that was the example that I was planning to go with. And then when I looked it up, I saw there were all sorts of consumer protection issues. I don't know if you know about those, around like signing people up with their credit card and then charging them. And anyway, so I moved away from that and focused on Book of the Month. Okay. In this fourth category, it's weird. So we couldn't really come up with an example in the fourth category. It's rare without systems change. It happens once you allow for a systems change, but the idea that you are using recommendations and then you are using recommendations, but you still benefit from being non-modular because the payoff from being right is so high, even though you're wrong lots of the time, can't think of really a good example of that one. It's also, in terms of the actual payoffs in the model, relatively low. Okay, Peter. Yes, absolutely. So errors are, so 2 points on this. So first, in our model, your recommendation system is perfect. Okay, so we don't have to worry about that. In the first version of this paper, we talked about modularity and stakes. Okay, because actually Tim Bresnahan in his paper talks about modularity and stakes. Stakes are essentially what you're talking about here, which is when you make a mistake, how big a deal is it for the organization as a whole? And so so I'll tell you where that leads you, and then I'll tell you why we dropped it. So where that leads you to is it's easier to adopt AI in low stakes situations for exactly the intuition you might have. So a bad recommendation in music streaming, who cares? A bad recommendation in immigration law is a big deal. So let's adopt AI in music streaming, but not in immigration law, or in terms of immigration decision making. So stakes is, so with that intuition, Tim emphasizes stakes as another, low stakes is another opportunity for AI adoption. But that's, and actually we've seen that, in the field. There's this company Matroid, what's his name? Reza Zada, who's a Canadian, but was a Stanford professor before he started a company. Has this company Matroid that are in the business of making low stakes predictions. Okay, so essentially they figured out this, let's make predictions no one else is making. And if we're wrong, it's not a big deal, but if we get some of them right, that can help an organization. So they did things like, let's set up a camera to figure out on chicken farms if chickens have the flu. Okay. No one's doing that right now. No one's really, you only know if your chickens have the flu once the whole flock has the flu. But if we can identify a couple of chickens that have the flu, that might save the flock. No one's doing that anyway. Sort of low stakes decision because no one's doing it. Or let's set up a camera to figure out if the advertisements that are supposed to be on the sides of trains in Mexico have been pulled down or spray painted over. Okay. No one's doing that. No one was really checking before. Low stakes. Hey, if we know that an advertiser was pulled down, or then the advertiser might, fix it and put up the new ad. And their whole business models around that. There's lots of reasons to think that. That's very much task-based. And so when we formalized it, we realized once you think about integrated decision-making, stakes and modularity become the same thing. So, which is the stakes and modularity are the difference essentially between getting the integration right, beta, and the in a non-modular system versus alpha plus gamma in the modular system. And so we got rid of the discussion of stakes because formally it's a distinct structure. Does that make sense, Peter?
Yes, thank you.
Yeah, no problem. Michael.
I'm just trying to wrap my head around it. And so on the field that you're saying it's rare without systems change, I'm wondering whether, let me check an idea to see whether I'm understanding it or whether it's wrong. But so what about websites that recommend a recipe which I can cook today, or that recommend a record that I might want to listen to without actually being able to sell it to me? Like, let's take this one step further. Let's say they're stocking them, they have a license for me to buy an MP3 from them if it's one of the very few licenses that they purchase, and they will buy the most popular ones. But they have an incentive to make a very good recommendation to me, and that incentive might come from my revisit probability, or a movie recommendation that might come from a revisit probability, or from the possibility to show me targeted advertisement, which is what apps do. So there's a third outside way of monetizing my viewership. And so basically then they want to do a very good prediction of what I like without actually being able to sell it to me. Would that be precisely the field that you're looking at here, and that you're saying it's rare?
Yeah.
Or am I missing something?
No, I don't I have to think about it more, but that's not how I was thinking about it. And here's what's different, which is that the emphasis in our framework is this idea that there's two different decisions.
Right.
And you just described an organization with one decision, which is what to recommend.
Yeah. So I would have to take it one step further, that they're able to show me a few films, like a few selected ones, but they don't necessarily want to limit their recommendation to what they can show me.
Oh, I see. Yeah. So no, well, that's an interesting box. I don't think that's here. So this box is really unintuitive. Okay, so so it's worth walking through a little bit. So it's a non-modular system. So what does that mean? It means you're getting you only get a payoff if you get the prediction right and you're aligned. Okay. You only get a payoff if you get the prediction right and you're aligned. Okay. So you don't get any payoff for getting the gamma right. So it's the benefit to this, to the modular, you want to be modular because the standalone payoff is so high. Okay. And then it's weakly better with the AI, weakly, because maybe in some, that's not clear that it's weakly better. Okay. Because you have to imagine a situation where let's go to the equations. So right, so you're only getting, right, M is 1, so you're really only getting a payoff here. And the difference is that if m is, the difference really is if m is epsilon less than 1, you're going to get more in this side of the equation. And so that's, sorry, that's on me. That's not clear here, and it should be. And hence the confusion. Farisat.
Yeah, sorry. I was just trying to figure out, again, I'm trying to understand between these modular systems versus non-ones. Other than the issue that, for instance, Netflix is a subscription-based thing, when they're making their recommendations, they're only making it based on what they already have in the inventory. So they would, movies recommended for Farasat would never show up with a recommendation that's not already in their stock. Would that be this fourth quadrant that you were, or would that not be an example of the fourth quadrant that you were showing?
No, Netflix is more like, this is Netflix. It's like Amazon. They make a recommendation, and they make a recommendation, but you don't have to listen to their recommendation. You can choose something else. And so the recommendation still has some value, because if they get it right, oh, your point is, I'm trying to think of Netflix. Okay,
Amazon can make a recommendation for a book or something, a product that they may not have in inventory. But Netflix would never make a recommendation for something that's not already in the inventory, because they only base it on their movies that are already ready to be streamed at any given time. Those that are not ready to be streamed would never show up in their recommendation list.
Okay, so that's not, I see. Yeah, I think that's outside the model, because it's not, and because the inventory, because they're not essentially independent decisions. Or wait, no, you know what? That is coming, maybe is the better way to think about that. Okay, that requires the ability to communicate between the two decisions, right? So the people doing the inventory decision need to know what's going on at the recommendation side. The people making the recommendation side need to know what's going on in the inventory decision. That's a different organizational structure than really we see at Amazon or at many insurance companies in terms of, say, their marketing and their underwriting, right? That is what we're thinking about as organizational change. It's a version of what Bresnan and Greenstein might have called co-invention, but Joshua says it's not invention, so he doesn't like me calling it co-invention, but so it doesn't show up in the paper. But it's the idea that now the AI allows us, if we can do things differently, the AI allows us to do much better. And what we're going to allow to do differently is something very simple, which is we're just going to allow a communication system. Okay. And so the return to adopting the system, is going to benefit when you get a bigger benefit of coordination. We're going to add a cost to it just to make it a little economically interesting. But so it's always going to be, as long as the communication system isn't too costly, you're going to want it with AI under certain circumstances. So now we have, if you can communicate, you're always going to be aligned. Because if you can communicate, now the decision maker one, who's going to make the prediction, no longer has to worry whether the other guy's aligned or not. Okay. So agent one is going to choose to communicate in action if they know that it's not the focal action. Of course, they're not going to bother to pay the communication cost if it's the focal action, because the other person's going to assume that it's the focal action. And so we end up with, you get in a modular organization both alpha and gamma. In a non-modular organization, you're going to get beta, which is bigger than the two of these two things, and then but you're going to pay some cost, which is C, subject to this sort of technical point that if it's the focal state, you don't need to bother to communicate. And so that leads to the final formal proposition, which is agent one's always going to choose to follow the AI prediction of communication as long as communication is not too expensive. And so if coordination is possible, what adoption does, it allows you to generate the modular payoff beta. And it's going to create incentives to be non-modular. Sorry, the non-modular payoff beta. So once you allow for the system change, now we get the opposite of, we get Tim's intuition, but not his description on modularity. And so what this relatively simple model does, we think, is it unpacks that tension where Tim said, all the big impact is going to be when you do a systems change. And yet when we observe adoption in the field, it's all in these modular situations, modular organizations. How do we make sense of that? Well, it is easier in modular organizations. But if you can change some way that your organization operates, in this context, we've modeled it as allow two decision makers to communicate, create a communication tool, then that moves incentives towards non-modularity. And it's the non-modular organizations that benefit most. So it's by writing down the model, we've formalized and understood this tension between the role of modularity and the system and task-based impact, big impact. It seems to be adopted in modular organizations, and yet the big impact should be all about non-modular organizations. Okay, so, right, and that allows us to go from this Amazon they recommend and have an inventory of separate decisions to Stitch Fix, where it's the ship without shopping. So as Tim said, my empirical conclusion about these applications is the lazy idea of AI is irrelevant to understanding how these technologies create value. That's not quite right. And it's not even quite right in the way he describes it. It's just an emphasis on task level substitution of machine for human plays no role in the most valuable of these systems because they're non-modular. The system-based view emphasizes modularity. It's a task-based view, his systems-based view. With AI's prediction, system means a change in how the organization operates. So that's our sort of the end of the formal aspect of this. Peter, happy to have a follow-up email exchange if you're interested. Amelia.
So I'm just trying to get my head around this as well. But in terms of liking communication, what you haven't looked at is the kind of time aspect of inventory building and then selling. And it seems to me that what you ideally always want to do is sell to the consumer exactly what they want, and to have got predicted the inventory so perfectly that you happen to have in exactly what customers want. And that's kind of your ideal. But if you are failing on that, you can do two things. You can do at least one thing, which is you can say to customers, we don't have exactly what you want, but we do have this other thing, which is relatively close to what you want. And that's in fact what Amazon does. So Amazon, if the top list, the top of the list of what's available on Amazon is essentially their best recommendation for you, given what they have readily available for you. So they have made an inventory decision, having a best guess on what people are going to want, but knowing it won't be that right. And then consumers, and then they then give the offer to consumers and basically refine the choice architecture for consumers, reflecting the decisions they've made on what they've got in, and that's partly because there's a timing issue, because they have to make the decision on what they're going to get in and what's going to get produced before they know what consumers are going to want. So I was just trying to understand what the communication does in your model. Is it that the communication allows the buying of the inventory to have better information about what consumers want, or is it to allow the consumer interface to be, like Amazon does, better at driving consumers to what we already have in inventory, or is it any of those?
So it would be doing both. So in our non-communication model, we've abstracted away. We've said you can't do either of those things. Inventory can't talk to get to recommendations, and recommendations can't talk to inventory. In our communication model, we've allowed both. And so, but you're absolutely right. There is somewhere in the middle where communication goes one way and not the other, which we could think about what that means. There'll be I have to think about whether that gives us anything in terms of the new insight. So to do that, so in the appendix of the paper, we say, the standalone payoff, was only about the recommendation system in the way I described it, and there's no standalone payoff in inventory. Okay, you can add a standalone payoff in inventory, and in the structure, in sort of the 4 propositions we've created, makes no difference. It just adds extra arithmetic. But once you have a separate standalone payoff for inventory, now we can think about one-way communication. And that might lead to some different conclusions than the two-way communication. I have to think about.
I guess what's interesting is
that
actually,
that's pretty good.
Actually, consumers care about both, because they care about what's the perfect choice for me, but they also care about what can I get tomorrow. And so both of those decisions are feeding in, and consumers inherently make second best decisions all the time, partly constrained by the choice architecture they're faced with, but also partly based on what have been the prior inventory decisions. Right.
And no, absolutely. And then if Amazon really had a great recommendation engine, where instead of 5% right, it were 90% right, then that would feed into their inventory decisions as well. And it would be much more like those dynamic issues would just disappear effectively. And they could get you, I guess 10% mistakes, but they could get you what you wanted they get you what you wanted when you wanted them. And so you never have to, their recommendations would be, they'd still be self-serving, they're a retailer and they're for profit, but they'd no longer be self-serving in order to get rid of their inventory. They'd be self-serving to figure out how to create, how to be profit maximizing.
I think
Okay.
you would also have to predict the arrival rate of types of customers, because one thing is predicting what the customer that just arrived wanted, but the other one is to understand what's the distribution of customers going to be in.
Right. So, yeah, we'll get to yes, you need to know the arrival rate of customers. You need to know the distribution. You need to know their location in terms of which still you're going to be shipping from. You need to know how many workers in that warehouse are going to be sick that day, and all sorts of other things that they do actually surprisingly have some attempts at modeling. But yeah, all right. Okay.
Okay, Avi, is this a good time to wind up the main core of the presentation, or is there a bit more you wanted to say?
There is. Oh, do you guys do like talk and then time for questions? Sorry, I was pacing myself at. Let me.
What we normally, well, I'll just tell you what we normally do is we have a bit of a invitation to some people who have to leave, because there's some people who teach right in the hour. They can leave. So we've kind of, and I think we probably have concluded the main content of the seminar. But then if you want to make any follow-up remarks, that's fine. And if people want to start talking to each other and asking more intensely questions afterwards, that's fine as well.
So my PowerPoint just crashed, but I want to say one more thing because you're a competition group. So I just want to talk about the implications of this for competition and competition policy. So I'll jump to that. That'll be a few minutes and then we'll wrap up.
Okay.
So this is the first thing to notice. This is prediction technology, right? So strategic change or not, it's going to be, the opportunities are going to be defined by data. Now, because can you make a systems change will require you to have, excellent predictions, which is only going to happen if you have excellent data. Now, how do you get excellent data? Well, your first reaction might be, well, you want more and more and more of it. There's some truth to that, but we got to remember our stats 101. And in stats 101, we know that predictions improve in the square root of n. They don't improve in n squared. And so there are decreasing returns to scale in data. In a straight stats technical way, there are not economies of scale in data. So we need to, if we're going to say that too much data creates a competition issue because it allows people to make these kinds of system changes, which is what's underlying everything, why you'd care. We need to have something else going on beyond just they have more data. So there's a few versions of it. One is they have uniquely useful data, okay, and the ability to combine it that others don't have. Why would one company have uniquely useful data and others don't? The one common scenario that we see is around privacy and regulation. Okay? If it is illegal for small companies to exchange data so that they can, have together a comparable amount of data to a big company, then the big company will win every time. And so this tension between privacy and competition, which is not, to my knowledge, embraced in the legal community. I think about these as the same thing. Hey, if we solve competition, we'll get more privacy, and if we solve privacy, we'll get more competition. If you think about the underlying economics of the technology, and just the and sort of the simple economics of regulation, if the privacy is happening through privacy regulation, that is very likely to help the big players, unless you want to actually go into the companies and figure out a way to audit and regulate who within the same company sees what data, which seems like, to me, a regulatory nightmare, but who knows? Okay. So just the key theme around this is, if AI is going to, if these technologies are going to allow us to build new types of organizations, that can create economies of scale if those organizations sort of have access to different data and different combinations of data than everybody else. Every time you restrict data flows through privacy regulation, especially data flows between companies, you're making it easier and easier for the larger companies to dominate. And so I've been sort of, before AI, I was focused on privacy in my academic research. And the last of those published papers was a theory paper, kind of like the one you just saw, on privacy and competition, just emphasizing that there's almost surely a trade-off. As an economist, I'd like to, sort of take a step back from the politics and say privacy and competition are both valuable. I don't know which one our society thinks is most important, but I can tell you there's no free lunch here, and that when you increase privacy, you're going to decrease competition, and vice versa, from a regulatory point of view. So that was Sean, that was just the last thing I wanted to say. I could have unpacked it every 20 minutes, but I'll just put it out there in 5 and then open it up to questions.
Okay, that's a fabulous final comment, and one that really speaks to a lot of people in the audience, I think, and is highly relevant to current policy debates, and and organizational questions about how privacy and competition regulators should operate and interact. Thank you so much, Avi. We'll give you a virtual clap right now. I don't know if you can see me, but I'll just you can imagine that being multiplied by 20 or so, and would really like to thank you for having come today. And now we'll move over to the informal part of the meeting where people can ask questions, or some people might run off and get some tea because we are, most of us, in the UK, and you should feel free to do that as well. But otherwise, feel free also to stick around, and a number of people will do the same.
Yeah, I have a tangential point to ask about. I didn't want to raise it earlier because obviously it's not part of the main talk. But this idea of having an AI that is predicting both the right inventory and AI that's predicting what matches the consumer's preferences ideally. In some ways, these seem to me complementary tasks. And I wonder if some of this goes back to the economics of when do firms, which used to be considered in the vertical integration literature, when do firms put together these two things in one roof and get vertically integrated and get a return from that? I'm not talking about necessarily Williamson transaction model type of thing or boundary of a firm, but I'm thinking more in terms of doing two things in-house and being very good at it, and you can be, there's a lower probability that you'll be extremely good at being able to do two things, and your efficiency will go down. But if you are able to do that, you'll avoid some of the transaction costs because it's all within the same firm, or in your language, non-modularized. But if you are in some way modularized, you have a trade-off because you draw independent draws of being good at predicting, let's say, inventory, or you can have an independent draw of being very good at predicting the inventory or what is necessary in the inventory. And when you do these two things together outside, you're mixing and matching in the sense that you're taking the best draw from one and the best draw from the other and putting it together. So you have an advantage of being in the modular sense when you're modularized, because that's what we would think of as two separated firms coming together and putting those ideas together. Whereas in the non-modularized, while you're getting your return to be beta, it is coming with a lower probability. So if we think of you drawing from a uniform distribution on how good you will be at predicting AI for, let's say, inventory, and you draw from another uniform distribution on how good you will be at predicting inventory, you've got two uniform distributions and you're putting those together. But if you're one joint firm or modularized, you'll be now drawing from a triangle because it's going to be the sum of two uniforms, which will become a uniform distribution. And so the draws need to be multiplied, I think, in some sense with these betas and alpha payoffs that you have, which can create a very different type of dynamics over here.
Yes, so that's exactly it, which is that you can think about if the value to the organization of getting one right and the other right is independent, you want to be modular, right? Because like who cares if you're not modular? You want to be able to get the decision A right, decision B right, and then just increase the chances that you get them both right. If the value to the organization is about getting A and B aligned, so even if the right thing to have an inventory is different from the right thing to recommend, then then you want to be modular. If in contrast, there's a benefit for full integration, right? So you don't even want to hold anything in inventory. As soon as you make the recommendation, you just ship it to the person. In that situation, now you have, it's multiplicative, exactly. So now you have a complement. Having both of them together is better than having just one or the other. And in that case, and it's only then having both together is better than one or the other that we get a benefit to being non-modular.
So in some sense, I think there should be a cost of communicating or transacting, but also a cost or an avoided cost of coordinating.
So yeah, so that's in there. So maybe that wasn't clear. So that's in there implicitly, in the sense that we have, if you're not coordinating, you get alpha plus gamma. And if you are coordinating, you get beta.
Right.
By assumption, beta is bigger than alpha plus gamma.
Right. Okay.
And so that's the.
So how much bigger it is going to be determined by that coordination part of it.
Right. Well,
Okay.
no. So the coordination part of it is a decision. How much bigger it is going to be sort of a driver about whether it's worth it to coordinate.
Okay.
So we think about the way we've modeled it, at least, is that the alpha, gamma, and beta are exogenous. Those are things that are true about this pair of decisions. And then that drives the sort of organization level strategic decision about whether to allow communication and whether to be modular.
I like the general model. Oh, sorry, Zita.
It's okay, Amelia, go ahead. I can't wait.
I like the general model. I was just trying to understand whether the model actually applied to what you're saying it applies to, because I could see that there are some models where some organizations where you'd have two different decisions with kind of independent likelihoods of them being right. But here it seems to me that there is this ideal, which is that you propose to consumers exactly what is the perfect thing, and the inventory exactly backs that up. So in a way, they are identical. They should be. They aren't really. They're absolutely not independent. I mean, inherently, and the right choice on both is inherently the same. And you've built in a bit of that by making it better to coordinate, but it seems much more extreme than that in this particular case. So I wondered whether this is actually the right motivating example for your model.
No, that's fair. So I like to think it is, but that's partly because that's the thing we were thinking about as we built the model out. We've been talking a lot about this idea for almost 5 years now of if Amazon's recommendations got good enough, they wouldn't have to bother having any recommendations. They could just ship things to your door. And so that shows up in sort of chapter 1 of our last book as a framework. And we've been thinking about that as system change for a while. So that's our own bias. That's not on you. That's like very much, okay. So had we approached it with fresh eyes, would we come up with a different example? Probably. But I do think with one caveat, which is if you look at how many retail organizations do currently operate, especially and including digital organizations that have automated recommendation engines, it does seem like inventory, it speaks a little bit to recommendation engines, but they're not nearly as integrated as you'd like to think they should be. So, Amazon's, their inventory does speak a little bit, but they still do recommend things that aren't in inventory. And then you click and it says, 4 to 6 weeks or whatever. And they certainly do have things in inventory that they guessed wrong on and that stay there for a long time. So, and Amazon, let's be clear, Amazon is the best in the world at this. So anybody who's second best, third best, think about like Home Depot. I don't know if you have Home Depot in the UK, but Home Depot online sells stuff that they don't really sell at Amazon. I think they sell it, but it's much more expensive and not as good. And they have a recommendation engine, but it does not integrate with shipping and vice versa. So I think it's, at least in terms of digital, maybe we should be thinking about it, to your point, as digital retail, but not using Amazon because they're almost too good. But thanks, that's a great set of questions. If you guys don't mind, I know we're almost out of time, but if you can give me a quick introduction to who you are before you ask a question because I'm sort of flying blind a little bit here.
Yeah.
Okay. Zita.
Okay, hello. So I'm Zita. I'm a part-time PhD student at CCP, and I'm also a competition economist. Previously worked for the Financial Conduct Authority and the competition consultancy. And I just have a clarification question on the intuition of the model and the role of AI in particular. Sorry if it should have been clear. Basically, what I get is that if you introduce communication between the different parts, then AI will have greater benefits. Is that a fair summary?
Yeah.
Okay. If you take AI out of it and allow communication, would you not get better payoffs just in itself? So for example, if you have Amazon and instead of AI, you have people sitting there thinking what to recommend, and if there are people sitting there thinking what to order, if you allow communication between those two units, even without AI, you would get higher benefits, wouldn't you? So my question is
much higher.
Yeah. Between how AI is adding value here.
So what that would do is guarantee you gamma, which is the alignment payoff.
Yeah.
But it wouldn't guarantee you alpha because you don't know what the standalone right decision is. And so what everybody would, there's an equilibrium where everybody chooses the focal action, which is a positive measure, right? And so everybody's choosing the focal action and you're getting gamma because both players are choosing the focal action. And you're getting alpha with probability rho, which is the likelihood that the focal action is the right action. And that's weakly better than anything else you can do. Because even with communication, you can always get gamma, but you're not going to get rho times alpha because agent one doesn't know what the right decision is. It's only with the AI that agent one has a prediction of the state so that they know what alpha is, so they get the right decision.
So you assume that without AI, the people sitting there cannot make a better prediction than doing the focal point.
Yeah, that's what the...
If you relax that assumption and say that people just by thinking could have a better idea, doing some research on the internet about what people are up to or something like that. Would
so
that
as long as it's worse than the AI, then the results will go through. We'll just have more parameters.
Okay.
So as long as the humans are worse than the AI, that's not going to make any difference to the main conclusion of communication being even more valuable. Yeah, then we're going to say, hey, communication helps a little bit as opposed to zero, sure. But it's still going to be much more valuable with the AI. It's just essentially all you're doing there is rescaling everything. You're turning a zero into a number and then moving everything up by one.
Okay, thank you.
No problem. Okay. So Amelia, since I asked you that question after, I asked people, do you mind introducing yourself?
Oh, sorry. Yes, I'm Amelia Fletcher. I'm Professor of Competition Policy at UEA, but I'm also on the board of the Competition and Markets Authority, and I was on the firm.
Fletcher. Okay, sorry.
Fletcher, yeah.
I know you were. Okay. I didn't know you were. Okay.
But no,
sorry.
it's really very interesting.
Okay, thank you. Okay, now, so yeah, anyway, I didn't put that together, but now I have. Okay, great.
Actually, I had another question, which is, I was trying to think through, so I really like the Prediction Machines book, and I really like the idea of AI as prediction machine, which is, I think, is absolutely right, and I hadn't quite thought it through before you wrote the book, so it was brilliant. But I was trying to think with what you were just talking about, whether there are risks in your organizational structure about getting the right data in to then enable the prediction. So I was thinking about your Amazon idea when they just deliver all the stuff to you. We do that. So in the UK, we have a supermarket called Waitrose, and you can do this, you can get home delivery. And if they haven't got anything in that you ordered, they just replace it with something else. And you can tell them not to, but you always forget to have a look. So you always get it. And then you can also hand it back, but you never do. So Waitrose probably thinks that actually I have very little, I don't care at all when they give me a big pack of crisps instead of the 5-pack that I needed, even though I needed the 5-pack to send my kids to school with little packs. And the big pack of crisps is still sitting in the larder because we'll use it one day. And so the question is there a risk that with the whole, if you kind of perfect things too much and recommend too much, you actually fail to get the information on what people actually like? And how do you get around that?
Yes. Yeah. So that's doing that right requires some like explore, exploit algorithms. Ultimately, is where that plays out. So you need to do reinforcement learning to, on the technical side, but the way we think about it in economics is if there's high variance and high uncertainty, you should sometimes just make ex ante bad decisions that allow you to learn in order to improve. And so, I've talked about this in another context a fair bit, which is in the context of hiring. So Danielle Lee has this great paper. I don't know if you've seen it. What's it called? She presented at our conference in the fall. It's AI and hiring or something along those lines. And what she did is this idea that algorithms are biased is bad, right? Okay, fine. But the algorithms are probably better than human on average, less biased, but they're still biased. And sometimes they're biased because they just don't have data. And so like Amazon got in trouble. They built an AI to predict who to hire. They didn't hire any women. Why? Because Amazon never hired any women. And so the conclusion of that was, oh, we should kill the AI. But actually, sorry, we talk. But actually the conclusion should have been, let's randomly hire some women who are high variance, who might perform well in the organization so that we can learn who the best women. So that's formally the best way to deal with that is to create learning algorithms.
So randomly, actually, in your model, you ought to have, if you want to be making the perfect model that then has the data, you ought to be sometimes recommending things that are completely wrong, so that you get people sending them back.
Yeah.
Okay.
Yeah. For things where your predictions are imprecise, or you think the world might have changed, or something like that. Yeah.
That's interesting.
And Danielle's paper is the best paper on that. She really lays it out clearly. Sorry, I don't remember the title, but
Danielle Lee.
Yeah.
So I guess I'd just like to thank you once again very much for having joined us, and I hope that someday when you're visiting the UK, we might be able to get you up here to visit in person, and really have more of that personal interaction that you can't get these days over the virtual world. But it's been great to have you here, and thanks so much for your presentation.
Okay, my pleasure. Thank you.
Okay.